Hi guys, today we're going to look at exercise 4a. In this exercise there are quite a few things to learn, the first being equating coefficients. Now, the first question we want to look at is where we're trying to solve for a and b in the equation x squared plus 6x plus 4 equals a, open brackets, x plus 3, close brackets squared, plus b. Now, for a start, I'm going to expand on the right. So instead of having the brackets, I'm going to get ax squared plus 6ax plus 9a plus b. The next thing to look at is where I have the x squareds. So on the left I have x squared and on the right I have ax squared. If x squared equals ax squared, it then follows that the coefficient of x squared on the left must be 1, so the coefficient of x squared on the right must also be 1. That tells us that a equals 1. Let's now look at the green. We've got the coefficient of the x. On the left we've got positive 6x, so positive 6 is the coefficient. On the right we've got positive 6ax, so the coefficient is positive 6a. Therefore 6ax equals 6x. Let's look at the third piece of information then. We've got positive 4 on the left equals positive 9a plus b. Let's write that down as well. Now, we know that a is 1, so that must mean that we can find b. In the green, we see 6ax equals 6x. That doesn't really tell us anything different because we already know from the yellow that a is 1. However, in the blue, if we substitute a as 1 into the equation, we can see that 4 equals 9 times 1, because a is 1, plus negative 5. b must be negative 5. It's not too hard. You just have to remember to equate what's on the left with what's on the right. Let's look at another example. So we want to find a and b once again. This time we've got x cubed plus 3x squared plus 3x plus 8 equals a, open brackets, x plus 1 cubed plus b. Let's expand on the right. So we end up with ax cubed plus 3ax squared plus 3ax plus a plus b. Let's go for the x cubed first. On the left we've just got x cubed, on the right we've got ax cubed. On the left, the coefficient of x cubed is 1, so therefore a must equal 1. Let's now look at the yellow. We've got positive 3x squared, and on the right we've got positive 3ax squared. We don't get any new information from this. We already know that a is 1, so we can't really get anything new from that, only that confirming that a is 1. Let's look at the green now. We've got 3x, or positive 3x, equals positive 3ax. Again, we know that a is 1. Let's now look at the purple, where we've got positive 8 equals positive a plus b. So a plus b equals 8. We know that a is 1 already. So therefore b must be 7. Not too bad. In this example, we have a lot of different things to do. It may be an idea to highlight or circle or underline like terms. Let's move on. In this example, they're asking us to show that x cubed plus 6x squared plus 6x plus 8 cannot be written in the form a, open brackets, x plus c, close bracket, cubed, plus b. Let's think about how we could do that. So for a start, I'm going to expand on the right. So I'm going to actually equate x cubed plus 6x squared plus 6x plus 8. I'm going to make that equal a, open brackets, x plus c, close brackets, cubed, plus b. Expanding that, we get ax cubed plus 3cax squared plus 3c squared ax plus c cubed a plus b. Let's look at x cubed first. On the left, we just have x cubed, while on the right, we have ax cubed. The coefficient of x cubed on the left is 1, therefore a must be 1. Let's move to the yellow, where we've got 6x squared, and then 3ca x squared. A is 1, we already know. So it must be that 6 equals 3ca. We then deal with the green. We've got positive 6x, and we want to equate that to positive 3c squared ax. So the coefficient on the left-hand side is 6. The coefficient of x on the right-hand side is 3c squared a. Lastly, we've got 8 equals positive c cubed a plus b. Now, we know that a is 1. That's given to us by the blue. C must therefore be 2, because 3 times 2 times 1 gives us 6. That's what we have from the yellow. 6, therefore, looking at the green, we know what C is and we know what A is now. So if C is 2 and A is 1, 3 times C squared would be 2 squared, which is 4. 3 times 4 times 1 would equal 12. That doesn't make sense. 6 does not equal 12. So the green, once we get to the green, it doesn't make sense anymore. So that doesn't work, and it means we can't write x cubed plus 6x squared plus 6x plus 8 in the form A, open brackets, x plus c cubed plus b. Let's now move on to dividing polynomials. So it asks us to divide 3x to the 4 minus 9x squared plus 27x minus 8 by x minus 2. Set it up like this. Notice I've written 0x cubed in there. That's because I do not have an x cubed in my expression here, but I have an x to the 4 and I have an x to the 2. You'll see why that's important in a minute. Firstly, I say x. How many times did it go into 3x to the 4? It goes 3x to the cubed, because 3x cubed times x gives me 3x to the 4. I then multiply 3x cubed times negative 2, giving me negative 6x cubed. Let's subtract 3x to the 4 minus 3x to the 4 gives me 0. 0x to the 3 minus 6x cubed gives me positive 6x cubed. I'm going to bring down the negative 9x squared as well. X into 6x cubed goes positive 6x squared. 6x squared times x gives me 6x cubed. 6x squared times negative 2 gives me negative 12x squared. Let's subtract 6x cubed minus 6x cubed gives me 0. Negative 9x squared minus 12x squared gives me positive 3x squared. Let's bring down the 27x. X into 3x squared goes positive 3x. Positive 3x times x gives me positive 3x squared. Positive 3x times negative 2 gives me negative 6x. Let's subtract. 3x squared minus 3x squared gives me 0. 27x minus 6x gives me 33x. Let's bring down the neg 8. X into 33x goes positive 33. 33 times x, 33x. 33 times negative 2, negative 66. Let's subtract. 33x minus 33x gives me 0. Negative 8 minus 66 gives me positive 58. This is the remainder. This is called the dividend, and this is the divisor. Up here, I have my solution. So we can say 3x to the 4 plus, or minus 9x squared plus 27x minus 8 divided by x minus 2 equals 3x cubed plus 6x squared plus 3x plus 33 plus 58 remainder. How we can write this is as follows. There it is, divided by x minus 2. It equals 3x squared plus 6x squared plus 3x plus 33 plus 58 over x minus 2. Think about it like this. If we have a fraction of 5 over 2, that would be 5 divided by 2. We can write that as 2.5. We still keep the remainder over 2. So 5 divided by 2 is 2 wholes plus 1 remainder. We don't say 2 plus 1. We say 2 and 1 over 2. The same way we say 3x squared plus 6x, 3x cubed, plus 6x squared plus 3x plus 33 plus 58 over x minus 2. Let's do that on CAS. The first thing we do is we enter our problem into the main screen. I write 3x to the 4 minus 9x to the 2 plus 27x minus 8 in brackets divided by x minus 2 in brackets. I then highlight it. I go to interactive, I go to transformations, and I go to proper fraction. I click that and it gives me the answer. Let's move on from there. We're now going to find the remainder when p of x equals 3x cubed plus 2x squared plus x plus 1 is divided by 2x plus 1. We don't need to do all the long division there in order to just find a remainder. We have the remainder theorem, which states that if a polynomial is divided by ax plus b, so 2x plus 1 in this case, 2 is a and 1 is b, the remainder is negative b on a. Another way you could do it is to just equate that to 0 and find out what x would equal. It would equal negative 1 over 2, which is negative b over a. Let's see how that works. For 2x plus 1, a is 2, b is 1. So p of negative b over a is negative 1 on 2 equals 3 times negative a half cubed plus 2 times negative a half squared plus negative a half plus 1. We equate our fractions and we find out it equals 5/8. Let's try this one, a little bit more complex. X plus 1 and x minus 2 are factors of 6x to the 4 minus x to the cubed plus ax squared minus 6x plus b. We want to find the values of a and b. We might actually leave this one till the next slide. We're going to run out of time.